Hello. Today we're going to be working on proving some theorems. The first theorem that we're going to look at is the right angle congruence theorem, and that theorem simply states that all right angles are congruent. Okay, so we need to remember what congruent means, and in geometry we know. So we're working with this theorem first. And in geometry, we know that when angles are congruent, that means they are the same measure. Okay, so here we are given that angle ACD and BCD are right angles. Okay, so we don't have our boxes in here, but we can add our box to the, ooh, that was ugly. We can add our box because we are told, we are given that these are right angles. And what we're trying to prove is that angle ACD is congruent to angle BCD. Okay, so we're going to start with our given statements. And our first statement is, I'm going to zoom in a little bit, makes it easier to write. So our given statement is that angle ACD is a right angle. Okay, and my justification here is that this is given. And our second given statement is that angle BCD is a right angle. And again, that this is given. Okay, and so step 3. So right now, all I've said is exactly what is in our given statement, that angle ACD and the angle BCD are right angles. Okay, so that's what we write. So our next step is to talk about what this means. Okay, so we know that a right angle, if it's a right angle, then we know that the measure of angle ACD equals 90 degrees. And we know this because that's the definition of right angle. Okay, well, I bet you can guess what step 4 would be then. If angle BCD is a right angle, then what do we know? Well, we know that the measure of angle BCD is 90 degrees. And again, this is by the definition of right angle. Okay, well, now we have that the measure of angle ACD is 90 degrees and the measure of angle BCD is 90 degrees. Well, because we have the exact same thing on both sides, can we use a property to put these equal to each other? Well, hopefully your answer is yes. We can say that the measure of angle ACD equals the measure of angle BCD. And that's because of the transitive property of equality. Okay? And now that's not what we're trying to prove though. We're trying to prove that these two angles are congruent to each other. Okay? So we can switch between measures being equal and angles being congruent by using the definition of congruency. So our sixth step here would be that angle ACD is congruent to angle BCD by the definition of congruent. Okay, so it's not as hard as we think. We're going to be using a lot of the same information in all of these proofs because we're trying to prove some pretty basic theorems. Okay, but remember we can't use a theorem in a proof until we've proven it. So now that we've proven that all right angles are congruent to each other, we have now proven the right angle congruence theorem, and you can use this over and over in a proof.